Why is computational fluid dynamics, or CFD, essential in the electrical and power industries? Well, the answer lies in the intricate dance of electricity and heat. Consider this. In the realm of electrical engineering, one of the most significant challenges is managing the heat generated by various components. Overheating can lead to equipment failure, safety risks, and a significant loss of efficiency. This is where CFD comes into play, acting as a virtual wind tunnel for engineers to observe and control the behavior of airflow and heat around electrical components. To illustrate, imagine the complex world of transformers, motors, and generators. With CFD, it's possible to study the flow of air around these components, pinpointing areas of high heat generation and low efficiency. This allows for adjustments and improvements in design, optimizing performance while minimizing the risk of overheating. CFD also plays a crucial role in the design and performance of cooling systems. For instance, the efficiency of fans and radiators can be studied and optimized using CFD, ensuring they maintain ideal operating temperatures. Now, let's delve into a case study. MR CFD Services in Electrical and Power Engineering. Here, CFD is used to simulate and study the performance of electrical and power systems. It examines the flow of electricity, component thermal performance, and the impact of external conditions. This simulation allows for the detection of potential problems before they arise and the optimization of system design. What's more, CFD can mimic the behavior of these systems under various operating scenarios, such as power loss or a surge in demand. This ability to predict and prepare for different situations is invaluable in the power industry, allowing for a level of planning and foresight that was previously unattainable. Today, CFD's role in electrical and power engineering is expanding. From battery cooling using phase change materials, or PCM, and thermal management of batteries with nanofluids, to the simulation of electric field effect on nanofluid heat transfer, CFD is pushing the boundaries of what's possible. In conclusion, CFD's role in the electrical and power industries is a game changer. It allows for advanced simulation and study of systems, leading to optimized design, improved efficiency, and the prevention of potential issues. Whether it's studying the flow of air around a transformer or predicting the thermal performance of a cooling system, CFD is an essential tool in the engineer's toolkit. So the next time you switch on a light or charge your phone, remember the invisible dance of heat and air that makes it all possible, guided by the unseen hand of CFD.